Good morning, afternoon, or evening, depending on where you are. Thank you for joining us today. Welcome to the first of 3 BIM 360 webinars for construction. My name is John Harridge with Autodesk, and I will be the host and moderator for today's session entitled How to Integrate BIM 360 into Construction Management and Integrated Project Delivery Classes. A little bit about myself. In my role as a technical marketing manager, I create learning experiences to inspire the next generation of designers, engineers, and builders to create a better world through the future of making things. Today, I'm delighted to be joined by our guest speakers from the University of Florida, Dr. Raymond Issa and Nathan Blinn, who will formally introduce themselves a little later on in this presentation. With that, let's take a look at the agenda for today's presentation. So here's a look at the presentation today. I will begin with an overview of the industry challenges and then move through the technology solutions and then move into our featured case study with University of Florida and then wrap up with learning resources, next steps, and Q&A at the very end. If you are new to BIM 360 or have already begun a trial of BIM 360 and looking for new ideas or applications inside the classroom, you have come to the right place. Let me begin by saying that over the next decade, we are seeing technology trends that will radically disrupt how we design, build, and operate buildings. In this webinar, we will explore how building information modeling plus the power of the cloud is transforming not only industry, but also curriculum through an academic case study with the University of Florida. So I'll start off with a quick review of the challenges affecting the construction industry. So here are just 3 examples of challenges facing the construction industry today and into the near future. By 2030, population growth, urbanization, economic expansion are forecast to increase worldwide demand for construction output by 85%. In contrast to this demand, the construction industry's productivity is very low, with just 25% of projects being completed within 10% of their deadlines. Add globalization into the mix, and we are seeing an enormous change in the world where project teams are not necessarily co-located and are increasing the possibility for error and miscommunication throughout the projects. But here's where technology can help. The takeaway here is that yesterday's mode of practice is not scalable to solve tomorrow's challenges. Let's face it, industry uses lots of different tools to address their need to communicate and collaborate across distributed teams. However, none of them fully solve the problem because they were not built for design-based collaboration. In the absence of purpose-built tools for design-based projects for the built environment, teams will continue to struggle with poor communication, delays, and rework, just to name a few. To meet these collaboration challenges, Autodesk has created a purpose-built solution called BIM 360, which I will share with you in just a few moments. So let me introduce to you a technology transformation that is taking off that we are calling the era of connection. As our society becomes more connected with mobile technology providing for anytime, anywhere access, it seems like almost anything is possible in the era of connection. In the context of building projects, we are calling this connected BIM. And Autodesk is at the intersection of this growing demand for more buildings and infrastructure and the democratization of technology. So what do we mean by connected BIM? Connected BIM is building information modeling plus the power of the cloud. It's a cloud-enabled, intelligent, model-based process that unites the design, build, and operate segments. Connected BIM makes possible anytime, anywhere collaboration while providing data continuity across the life cycle of a project and also providing deep insights to improve decision making. So now I'd like to quickly review our connected BIM technology solutions. So BIM 360 is a platform of services designed to accelerate project delivery and to help minimize risk across the project team. BIM 360 provides a shared, cloud-based database of project information that makes the database easily accessible to all stakeholders at any time from anywhere, connecting all the project teams across AEC. So here's a listing of BIM 360 solutions and how they fit into the design and construction phases. The entire BIM 360 family is cloud-based, providing anywhere, anytime collaboration access to inform to information across the project team. Team members can access services from their desktop or mobile devices. Now let's take a closer look at some of the BIM 360 tools that are featured in today's presentation. Let me start off with BIM 360 Docs. This is a cloud-based service that provides tools for publishing, managing, reviewing, and approving all project plans, models, and documents from a project's earliest phase through owner occupancy. Next up is BIM 360 Glue. This is a cloud-based management and collaboration tool that empowers multidisciplinary teams to accelerate 3D model coordination and clash detection of building systems in one location. Now I'll transition over to Collaboration for Revit, which is a cloud service that works with the Revit desktop design software to provide building design teams with centralized access to BIM models in the cloud that provides simultaneous co-authoring of models across companies, geographic locations, and even across firewalls without major IT investments. In addition, Collaboration for Revit includes project-specific communication software that lets team members connect through direct, real-time chat within projects. Paired along Collaboration for Revit is BIM 360 Team. BIM 360 Team is a cloud-based workspace providing all team members, whether you're designers or non-designers, with centralized access to information to make team decisions faster and in real time through a web browser that provides access to 2D and 3D design files as well as Office project documents. Users can comment and create markups of a design document through the web browser without affecting the Revit model. So now I'd like to reintroduce to you Dr. Issa and Nathan Blinn of the University of Florida to share out their story on the integration of connected BIM solutions from this past spring semester's course. And Dr. Issa, the floor is yours.
Thank you, John. Hello, everybody. So our agenda for today is introduction, the BIM BDC and education, connected BIM case study that we at the University of Florida, the lessons we'll learn from using this in the classroom, and recommendations we have for you for integrating the software. As far as BIM virtual design and construction education is concerned, just to give you some background, the University of Florida was established in 1853. It's a member of the American Association of Universities. It's a Carnegie Research RUVH institution. Our enrollment is 53,500 students, about 25% of which is graduate students. Our annual research budget is about $800 million. Our nickname is Gators, and the NCAA conference is the Southeastern Conference. Some facts about the school: the Bachelor of Science degree was established in 1935, the Master of Science in 1947, the PhD in 1988, and we started distance education graduate degrees and undergraduate degrees in 1999. As far as enrollment is concerned, we have about 400 undergrads, 120 master students, 50 PhD students, about 35 distance master students, and about 150 bachelor's, master's, fire and emergency services students. As far as technology is concerned, I like to emphasize that BIM enables creativity. Here you can see the Disney Concert Center designed by Geary, the paper rendering. Then the next image is the VDC representation of the building. Then we have an actual picture of the steel structure of the building. And then this is the completed building. We don't think that this building would have ever been constructible without these building information modeling tools. So the goal in using BDC is to build virtually first. So that's the goal. So we in the classroom, we instruct our students. Sometimes we give them regular two-dimensional drawings, and the goal there is to get them to convert this in a virtual construction process so they can understand the construction process as well as learn how to interpret the design. As far as the technology and construction education is concerned, in your traditional construction project, The image on the left represents the communication. It's all over the place, everybody communicating through everybody. In the BIM information exchange, we have the cloud connected BIM as the hub for all the communications and the sharing of knowledge among all the parties to the contract. The way things were done in the past as far as clash detection is concerned, and some people still do that nowadays, believe it or not, is to place a bunch of sepias on top of a light table and try to detect the clashes. Whereas using our building information model in the connected world, we can three-dimensionally see all these clashes and better be able to ascertain what they are and the significance of these clashes. As far as the inefficiencies of the current system, using connected BIM allows us to reduce rework costs by 26%. And that rework cost in the design area, 28% of that 26% is lack of coordination. Unsuitable design is another 18%. Faulty design is 13%. And you can see the rest there. As far as from a client aspect is concerned, changes initiated by the client are reduced by 34%. Bad choice of materials and methods are reduced by 15%. So that amounts to about 6% reduction in rework costs. And of course, from a construction standpoint, the production management is important because that's 25% of the rework cost, and mistakes in planning constitute about a quarter of that 25%. Faulty work preparation, 15%. Faults in material administration, 16%. As far as the cost of VDC, the rule of thumb is it's anywhere from 0.1 to 0.75%, so that's about less than 1%, of course. And here you can see some building types, the project cost, the VDC cost, the percentage of the VDC cost, and of course, more importantly, the return on investment for the VDC cost. As far as BIM VDC contributions in construction education are concerned, as you can see from the previous slides, we allow students to practice the latest construction industry workflows. So that's why we engage in VDC. That's why we engage in clash detection. That's why we engage in project construction simulation. The availability of cloud-based services from Autodesk provides us access to real-time collaboration and allows the students to experience the best practices and the latest best practices for construction. Industry collaboration in the classroom takes the form of content updates. They're continuously visiting with us and helping us develop new content. Sometimes they're presenting this content to the students either in person in the classroom or remotely. They provide us with exercises, practice exercises for the students, and of course they sponsor and mentor our nationally recognized championship VDC competition teams. We also get input from the industry advisory board. They're constantly pushing us to improve our BIM and VDC in the classroom. This has led to 2 undergrad classes, 1 grad class focused on BIM, and also an energy modeling class focused on BIM. So in addition to that, we also have a special topics course for the VDC competition team that involves a 6-month-long training before the national competition. As far as developing faculty expertise, we couldn't do any of this without the input and help from our graduate student teaching assistants. So course delivery method is a collaborative effort between the faculty member and the grad students, and mostly the grad students are concentrated on the hands-on portions of the class and the faculty on the theory portion of the class. The lectures are also recorded and students are given access to them immediately following the class. Outside classroom time is expected from the students for self-learning, collaborative problem solving, and that's why we use all this connected BIM software to help enable and encourage this self-learning and collaborative problem solving. The graduate student TAs work closely with the faculty and students to provide hands-on training and expertise in the courses. Next, I'm going to pass the mic on to Nathan Blinn. He's an exemplar of our grad students who are involved in helping us do the hands-on portion of the class, and he'll talk to you about that portion.
Hello, everybody. My name is Nathan Blinn. I'm a PhD candidate here at the University of Florida. I focus on virtual design and construction technologies and their integration in the industry, as well as on the education of future professionals related to building information modeling and the various virtual construction technologies that they'll be exposed to when they begin their careers. What I'm going to talk to you about today is the case study that we did using BIM 360 and the way that we integrated it into our classroom. So I'll start by introducing the class that we did so you can get a feel for the kind of course that we work with to kind of compare it to your own and see kind of how that can compare. And we'll also make sure that we're providing you some examples of how that can be, how what we did can be adjusted to fit really any range and a wide range of course types, and the way it can be integrated into a variety of curriculum across the construction and design spectrum. So the course that we use is called Construction Information Systems. It's a 15-week course, so one semester, 15 weeks on average, depending on how the year goes and how hurricane season treats us. And then we have each week about 3 hours of class time, and we do that consecutively. So it's one 3-hour block per week, as opposed to smaller 1-hour chunks, which allows us to get a little bit more in depth with the students and do a lot more hands-on activity. We use the basic Autodesk platforms that you see there, as well as the BIM 360 platforms that we've integrated in the past year or so. We also expose them to a range of other technologies, and we really try to focus not so much on the button pushing and the how-to, which while we do that and it is important, we try to make sure they understand the theory behind what they're doing with all these things, how to manage all this technology, and how it can affect their careers and provide them the best advantage when they move out into the industry. The way technology is integrated into the class is we have our coursework broken down into kind of two areas. We have individual class assignments and we have team projects. So the individual coursework that we do is focused on this building you see up here at the top on the right of your screen. That's a building that we designed specifically for the class so that we could control the drawing set, we could control all of the information they have, and provide the students with probably the cleanest set of drawings they'll see in their careers, so that they can focus on the development of their skills in the course, rather than focusing on trying to find information. We introduced that in the team project, where we've partnered with our local school board here in Alachua County, Florida. They've given us access to their plan room and their drawing sets for all of their schools in the district. We're able to then have the students provide them and build as-built models for them, inclusive of all the building systems, architecture, structure, mechanical, plumbing, and electrical, to be able to provide them to the school board and do a service for them where they can then use these for energy use down the road. So it really does help our students have some, I guess, skin in the game, where they know that these models aren't just going to be turned in and sit on our computers. They're going to be used by the county and by the cities that we live in. So each one of these models, you might kind of be asking yourselves, well, that's a lot of work in one semester, so what level do we have them do it to? We expect about a level 300 BIM development by the end of the semester for each of these. So by the time they leave, conceivably, as long as they've followed the plan, they will have developed two fully functioning, fully information-loaded models to level 300. The classwork models we use to focus on the building of fundamental skills, which you're going to hear me talk about that a little bit here moving forward. And we really try to make sure that they're focusing on developing those best practices and those kind of workflows that are going to really help them in their careers. And we try to also make sure that they realize that even if they never use this technology to physically model something again, that it's something that they're going to have to manage in their careers, and that they need to understand what they're asking other people to do and what their expectations should be. On the group project, we focus on the collaborative side of things. So we really ask them to look at how they're going to leverage this technology in the most effective way to get to a successful completed project at the end of the semester with their classmates. So we put them in groups of anywhere between 3 and 5, depending on the level of difficulty of the school, as well as the background of the students. And in this course, we don't just have construction students, we have a range of students that come from civil engineering, architecture, a few from urban planning, and construction as well. And they all have a range of backgrounds. Since it's a graduate level course, We have some students who come in with industry experience, years of industry experience, and we have some that are coming directly from a bachelor's degree. So it really is a nice diverse group, and we work with them to create the groups in such a way that that experience is going to be beneficial to them moving forward. So when we move through the class, this is something that I think everyone is pretty familiar with, is the levels of BIM, right? We really start by focusing on the 3D modeling side of things and allow them to kind of get their feet wet and get their direction, everything kind of focused in the right direction so that they can start moving on to adding in additional layers of information through scheduling and estimating and really using that information. So by building those skills in the 3D modeling stage, we try to prove to them the importance of doing that correctly so that that information can then be used down the road. So the ones who heed our advice have a pretty easy time when they get to scheduling and estimating, because the information built into the models makes that a pretty smooth transition. Those that didn't necessarily believe what we said find out pretty quickly that the importance of clean information input and of doing things in a methodical way and in the correct way can really aid later down the road. And I think it's a good lesson for them to learn before they get out into the industry. And we'd rather them make that mistake here than when they're out on the job site. So those foundational BIM skills that we start with, we focus on the desktop applications primarily to begin with. So we focus on Revit, Navisworks, kind of those desktop applications that have interfaces that they're familiar with and have very similar workflows to what they do in their everyday life. You open a file, you start a new file, you save it. That's how you move things through. So we kind of let them get their feet under them in this new world of 3D design and information. And then we focus on everything that we do. We try to make sure we're focusing on the best practices as well as the management of the information and the models themselves that they're going to be going through to make sure that they understand how important it is that all of this is done cleanly. We always try to use the example that, if we have you all switch models tomorrow, everyone should be able to understand exactly what you were doing in the model and everything should be clean. It's kind of, if we found that when we start doing that from the very beginning, it really helps them down the road build those good habits as they move forward in their careers. So we start with, at the basic level, we start with Autodesk Revit, where we work on the modeling skills themselves as well as the input of the information. That eye is crucial to us, and we make sure that they understand why. Next, we go through and try to prove that to them through Navisworks, where we look at different model coordination, the addition of scheduling and estimating, as I mentioned, and try to work on the extraction and the utilization of that information so that they can understand how data-driven decisions can be made through the use of building information modeling. And finally, the part that we're going to focus on today is the connected BIM. That's the more advanced side of things, and that's the part where we try to get them to, is to be able to use these cloud-based solutions and do things in a much more collaborative manner and really harness the power and the potential that these platforms have and can have on projects in the future. So again, here's that classwork model that we do to give you an example of the kind of detail they're provided when they're building those foundational skills. So the detail that they're provided here, you can see a plan and a schedule down at the bottom. The model we designed it and built it in Revit. We made sure that everything worked, everything functioned appropriately. All of the information embedded in the model was done through Revit to ensure that they should not have any problems logistically with the building itself, other than building their skills up, and we can provide them any level of information they need along the way. And this is where we start that process I was talking about, where we really, while they're not necessarily designing it, we ask them to start from scratch. So we ask them to start from that semi-design phase where they're putting in plant grids, they're putting in levels, and it really gives them a sense of ownership as we move into the connected BIM side of things. And then once we're in pre-construction, they have to use this to find errors in their model. So we encourage them to use Navisworks and get them familiar with the collaboration and coordination tools available there that transfer directly to some of that BIM 360 platform work that they're going to do later, unbeknownst to them. And then we explain to them and make sure they understand the advantages that these things have in the construction process and through the commissioning phase of a project. So now on to the meat of why we're talking today and why hopefully I think all of you logged on, which was to see how group project learning through connected BIM and the use of BIM 360 platforms can really aid in the educational experience of students and provide a new way of doing things. And that leads me to, I'm sure you're kind of wondering, why would we want to do this? It's an important piece of technology. We can see that people in industry are doing it, but why do we want to do it? Why do we want to go through this effort for our students? And what we've found is that the industry workflows that they're going to be experiencing when they graduate really do align with this BIM 360 and the cloud-based ideas. Our industry partners have indicated this, and the number of students that come back and tell us how helpful it was to be out on their first project and to know how to touch these things and kind of get through these models and to not be lost when they're sitting in a meeting with all of these senior team members was really great for them. The other thing it does on a more educational level is it provides them greater efficiency in what they're doing in the classroom so that they can focus on developing the skills and understanding of what they're going to eventually be managing or doing, while eliminating some of that administrative type pass back and forth of models and information, and it really does help them become more efficient. And in that same vein is it improves their ability to collaborate with one another. So we all know that students in group projects can be trying for students, even though they're co-located, and it's probably the easiest they're ever going to have to get in touch with people on a project. But we really try to have them understand how leveraging this software can improve their ability to collaborate. So they don't need to try to fight to find a time a couple times a week to get together. They can be working in their own apartments, in their own locations, and use the software to their advantage to try to do these things. And it really does, we found, improve their progress throughout the semester. We all know procrastination is a thing that we deal with, and I think having this sense of accountability where in the BIM 360 platform, everyone can see what's going on the entire time really helps kind of prod them along throughout the semester and keep things moving, which we think produces a better result. And finally, that knowledge sharing. As I said, our students all have diverse backgrounds, and so the ability for us to share our knowledge with them and for them to share their knowledge with each other really is a benefit that we think is worthwhile and why we went down this path with our coursework. So we look at the way that we integrate connected BIM into the classroom is not all at once. What we do is we build upon the skills that the students already have, and we try to introduce these things little bit by little bit to not overwhelm them and to make sure it's the smoothest transition possible into what all of these can do. So we try to add the new concepts in an order and in a way that will be minimally disruptive to what they're comfortable with, so that they're not kind of shocked into resisting this new technology, and making sure that we do it that way has proven to be helpful. So we start with our cloud-based model coordination. So as I had mentioned, we use Navisworks to do some of that with our classwork projects. So we introduce this connected BIM concept for the group project so that they can start to do that. And what we do is we start with BIM 360 Glue, as that is something that they're kind of comfortable with. They're comfortable with that idea of coordination, of bringing models from Revit into a different environment and viewing them and reviewing them with their teammates. And all this does is shift that from a physical desktop location into the cloud, and it kind of gets their feet wet in this BIM 360 platform. Next, we move on to BIM 360 Docs, and that's where we encourage them during their group project to use Docs to manage their files, to be able to pass them back and forth, and as a location for them to kind of store and archive things. And we also require that this is how they submit models to us at the end of the semester. So we no longer want flash drives, and we try not to tax our kind of native university file submission platform, which really wasn't made for multi-gig models. It was made for small documents and presentations and things. And so we try to make sure we do that this way. And honestly, this is a more realistic way that they'll be sharing files in the future. And then our final kind of the holy grail of all of this is the culmination of all of it into a collaborative BIM process through BIM 360 team and the built-in and native collaboration for Revit, where we encourage the students to work in one modeling environment together. And so I'm going to go ahead and step through each of these and explain to you how we've done it and kind of what worked for us and what we found through this process, and then talk to you about kind of the time commitment you can expect, as well as some of the things we learned. So hopefully you can learn from some of the things we went through and really have a much better chance of success moving forward. So we start with BIM 360 Glue, as I mentioned. This is where things fit into that construction workflow, and you can see that technically we kind of jump around a little bit, but I think that we do that in a way to make sure that they understand that things are not linear, and that when you move from Glue, which is the platform that they're familiar with, and then get back to that design part, while we're not an architecture program, we really want them to use that BIM 360 team in that design portion and collaboration to work together on making these models work and making things go smoothly as they all try to combine their projects. So with BIM 360 Glue, what we try to do is connect them with familiar platforms and build upon what they already know, and do that in a nice smooth process. So here's that team project process we developed, and here's how we integrate this into our course. We've used BIM 360 Glue in the course for a number of years now, and have found some great success. So what we do is we create those projects for them in Glue, provide them access rights. Each team has a captain, or a technology leader, I guess you could call them, and they're the ones that are given full access rights to the project so that they can add files, or they can remove files and create those merge models and do some of the things to kind of simulate what it would be like on a real project, where not everybody has full access except to be able to upload projects. What we expect them to do once we get through their initial introduction to these things is they publish their models weekly. In ideal situations, they can open those models and view them in class. When we work with them, and I work with them every week, we try to go through these models and look at their progress, see any pinch points, some potential areas where they might need to be kind of tugboated back onto a different path as they stray a little bit. I mean, we encourage them to merge their models with each other's models to be able to analyze those throughout the entire process, and really kind of get to a good conclusion without having some major hiccups at the end where things don't align. And the example I have down there on the bottom is one building, but the schools that we get from Alachua County, since we're in Florida and it's sunny most of the time, except for these days at 3 o'clock every day, it seems, we ask them to really focus on the ability to work in an environment where multiple models need to be coordinated in space. So our schools are designed in such a way that it's not one building with one front door, it's multiple buildings on a job site. And so this allows them to make sure that they're in the right place, that their models are on the site in the right place, and they're working together the correct way and can connect. So some of the benefits we've found, and you can see the example of that up on the top. We had some of our overachieving students put in the baseball diamonds as well up there. What we found was that the real-time collaboration that they have, the ability to find those mistakes early on, where if a building isn't located correctly, they can course adjust really quickly, and it doesn't happen the week before the project's due. That's something that they've really bought into, as well as making sure that they're kind of in sync with the things that are happening. So it allows them to kind of self-monitor their progress and help each other out when needed if they're not going to hit a deadline that they've set for themselves. The other thing it does from our perspective is it improves their comprehension of the things that are going on within the model. So when everyone's working in their own silo, especially because you can see some of these buildings up there seem pretty similar. So they come across similar problems, and this provides them the first step into the ability to see if those problems have been encountered by somebody else and address them appropriately. And kind of one of the more important things for us is that this is an industry workflow that is very common, and so for us to provide them access to that and to at least have them with an experience in it is really crucial. And it's our first stage to be able to interact with them more than just during the one class period, where we can log on and see those models weekly. We can check in and see who's been uploading what, who's been working, who hasn't, and kind of keep track of how progress is going throughout the semester. The next platform that we introduce is the BIM 360 Docs platform. With this platform, we try to focus on the hosting of models, as well as showing them how they can have simultaneous access to these models and these things. And it provides us access as well to be able to help work with them throughout the semester outside of class time when they're finding that they have some issues or potential questions. So this is where we get into that construction phase, where we make sure they understand that this is a platform that they can use to manage a project, right? So they'll be putting the models up there, they'll be using those to manage the flow of information through the different project stakeholders, and that's where they get involved here. So what we have within BIM 360 Docs is this is an example of what one of the projects looks like that we set up, where up in the plans category up here at the top, what you can see is you have a building models and a site and federated models category, which we created. And what they have up there is the ability to put their models, and if they have sheets embedded in their models, or if they create sheets, which they're encouraged to do, they automatically show up, and they can look at the 3D views and write comments to one another. So you can see this box that just opened up down there. They can actually go in and write comments to one another in their models in this environment. The other thing that they can do is compare and look at who's modeling what as far as the different systems are concerned, to make sure they're all focusing and heading in the right direction and making sufficient progress. The next part of it is the project files portion, which is at the bottom, which is very smooth and easy for them to get used to, because it's very similar to any sort of cloud hosted document location, except that it's really custom tailored to the modeling environment into the Autodesk environment. So it's a very smooth transition. It allows them to host their models, and this is actually where we have them submit their projects at the end of the semester as well. So we create this structure for them that they have to submit everything that they do to us for grading and for their actual submission in that way. And what we can do is, because we have BIM 360 set up in such a way that we can restrict their access at the given project due time, we go in and restrict their access from the ability to upload or modify files to simply be able to view files. So that up until their presentation, they can still view their files and go through them with each other, but they can't make any changes, and it allows us to get in there and look at things right away. And while they're giving their final presentations, we can see their models and see kind of maybe some things that they're not showing us in the presentation that we'd like to discuss. So if we go into the models category, they upload their models directly, and you can see that it actually has version control as well. So they can use this as a way to see kind of, keep track of their archive models and make sure that they're versioning appropriately. The next thing that we do, and this is really for me, one of the really most exciting parts of the BIM 360 platform. My undergraduate degree is in architecture, and I had used the central model platform quite a bit as far as being able to model in the same place. And collaboration for Revit and BIM 360 team makes that a much smoother process, and it allows you to access it from anywhere. So there's no need for that physical server location. It's all in the cloud, and it really opens up the doors to a lot of collaboration for the students, which we found has been beneficial. So what we end up doing with them is we go through and we show them how these tools are embedded in Revit. You can see up at the top here of this screen environment that I provided, that communicator bar and that central bar here in the Collaborate tab is really where all of this happens. So it's all built in natively into the interface they're used to. And so there's no learning curve of a different interface. It's all right there. They don't have to download anything new. It's all part of what they're already doing. We're just kind of unveiling new functionality that they might not have known existed yet. So what we try to stress with them is that this is real-time collaboration. Not only can it provide interaction between the students within the group, but it can provide interaction with us as well. So getting them to come to office hours can often be a challenge, even though they have questions and things they want to ask. But what we found is through this environment, during office hours, if I have my Revit window open and I can log into their model through the A360 platform, we can have a conversation right there and solve some of their problems pretty quickly. As I'm sure some of you have experienced, the problems they come across can be very easy to solve if you just take 2 seconds to look at it, and it's kind of an aha moment for them. And this enables that to happen from anywhere and in any place, and for us to have the ability to look directly in their model without having to share those things. So we encourage them in the group project to try to create one master model that they can all work in. And the big thing that we try to explain to them as to why it's important to do it with this tool is that not only will it reduce the amount of duplicated modeling efforts they have, so family creation, creating families can be very time extensive depending on how intricate the families are in those schools, whether it's walls or door components. And so by doing it in this environment, now everyone has access to those. So we're reducing the duplication of effort, and we're reducing the potential for someone to overwrite things, because this has kind of built into it a check-in, check-out process where once you start using an element, it's checked out to you, and the only way someone can get it is to send you a note asking you to release it back. So you kind of eliminate that potential error, which we have seen quite frequently in the past when they use other cloud sharing platforms. If we look down here, you can see the collaboration windows open down on the right, and it has the few names of us that we were in there working on this model, being able to talk right back and forth. And like I said, it's all native, and it makes it very easy for them to use. So this is an example, actually, of one of the student projects and some of the conversations that they had with one another during the course of their modeling. So over on the right, they have we have the communicator open. I did remove their names and type user 1 and 2 just for cleanliness there. But you can see this team had 5 separate conversations based on different modeling systems and different buildings within the project. And so they were able to actually talk back and forth. They used it quite extensively while they were working from their individual terminals. So in this situation, we had one of our students was asking the others about, a lack of information they found. So some of the buildings we have them do can be as old as the 1920s. So the information you can imagine in those as-built drawings isn't necessarily the cleanest. So they were trying to work through what that could be, and they ended up kind of deciding to make it up based on what they knew from the other buildings and showed some examples. And then they were adding in some of that structural information. So they were actually working within the same model and creating that family and adding the structural information together, which was a really great thing for us. So the other advantage that this platform provides that I think is worth note is that it provides accessibility from anywhere. Anywhere that you have a computer terminal with Revit, all they have to do is log into their Revit account up in the top right corner where we're all used to signing in. Once they sign in, they have access to open any of their models that they have saved in the A360 platform up in BIM 360. So when they come to the classroom and they're in the lab, they no longer need to bring their flash drive or bring a hard drive with them and then make sure they're saving back and forth. They can just open up Revit on the computer, log in, and they have access to all their models. So they have access to the most recent things. And what that really does for us is it allows us to work with them continuously on their projects without having to worry about file transfer. We can log on our own individual computers. They can log on theirs. And every week I meet with them to go over their progress, and they bring these up so we can show and look and see what they're doing and work through some problems pretty quick, and help them continue making that progress. And it also does save those local backups, which is something they're always concerned about, is what happens when it crashes. And so it saves those backups and allows them that efficiency. Now, one thing to note with this is the BIM 360 team in this collaborative environment is a high trust environment. So if someone makes a change to the model, that change is universal and it happens everywhere. But what it does here is if mistakes are made in the classroom, they can learn from those and it doesn't have a potentially large impact on a bottom line somewhere. But what it does is it gets them used to this idea of a high trust environment where everyone has access to things, everyone can see what's going on, and it can be a continuous workflow from top to bottom. So I'm sure as we've been talking about all this, the question in the back of your mind has been, well, how much time are you spending on all of these platforms to get them into the classroom? I know we're all busy. We all have a lot of things that we're trying to do, whether it's publications or learning new technology or anything like that. And so time is important. So what we've kind of done is broken it down into the level of effort you could expect for each of these platforms. And the first one we start with is BIM 360 Glue. Honestly, less than an hour a week of additional time. I think all of these are all, of course, dependent on how much you or your TAs or your assistants or your fellow professors would like to spend on working with the students collaboratively in these environments. But honestly, setting it up initially can take about an hour. Just to get all your students in there, get the permission levels set, get all of that done. And then after that, it's pretty smooth. There really is not much moving beyond that. Glue is something that they're going to use to do their work, that you can use to check in on their work and to see how they're doing and what they're doing along the way, but it doesn't require any additional input from you along the way. The next platform was BIM 360 Docs, and once again, this one really is under an hour a week. It's more of a tool for them. So it takes some of that potentially non-productive administration time that they used to have of transferring models, trying to set up a site and do those kinds of things, and allows them to really use it productively to look at each other's models, to manage that information, to make decisions about what needs to be done. Do we need to adjust our schedule? What do we need to do? And so this is really all on them. Providing them access to this is something that will provide them potential greater efficiency, but doesn't put any more work on the instructors. All it does is allow access for us to go in and look at what's going on, and it really is beneficial. And finally, we have the collaboration for Revit and BIM 360 team edition, which is kind of our best case scenario. And as you might have guessed, that one does take a little bit more time, as it can be a tool that you use to work with them. But the one note I have to say on that is that it can take up to 2 hours a week of time. And I'm including that in the office hours and the time I spent with students. So I have office hours every week anyway, so it really doesn't add additional time to that. What it does is it allows for greater efficiency within that time. So about probably 1 to 2 hours a week I spend working with the students in this way and collaborating with them back and forth. So it really is an effective way to do those things. And we think it's well worth the time that it takes. So cumulatively, you can probably expect between yourself, your fellow professors, your students, maybe 2 hours a week of additional time, if you don't factor in that some of that is going to be during office hours anyway. And so that's really to be able to capture all of this and provide the students with the benefit of the entire platform and show them those examples and give them that experience that we think is extremely beneficial to the rest of their careers. So just to kind of recap, we start with that foundation. So any course that you're going to try to do this in, that foundation is crucial. In order for the students to get the most out of the BIM 360 platform, They really have to have their feet firmly planted in those desktop applications and in what is the foundation of building information modeling, in that modeling and information management area. Next, you add in those BIM 360 pieces, and you do that kind of a little bit into the semester. We typically start at a few weeks in, where we start slowly introducing these things and bring them into the future of collaboration and building information modeling. So now that I've talked about kind of what we did and how we did it, I'd like to talk a little bit about some of the lessons learned, some of the things that we've come across that we're going to work on doing better, and we have done better since we started this process. Some of the things that we found that worked really well were, first of all, just gaining access to the software. It's all cloud-based, so you don't have to download anything new. And working with John and the team at Autodesk and through the education grant that you can get for these things, the licensing is extremely easy, and it makes it a really smooth process to get moved through. Next, gaining that relatable experience to the industry and tying that in with some of the industry professionals that we bring in was a huge benefit for the students, to really feel like they weren't just doing something for a class, but they were gaining valuable life experience that's going to aid in their careers moving forward. From this educator perspective that we have, it allowed us to not only collect the assignments in one unified location, it allowed us to review those assignments, to monitor their progress, to keep track of potentially who on teams wasn't doing as much, and kind of keep our pulse on that so that we could provide some course correction if they were steering too far off the path towards a successful project. It gave us that instantaneous access when they had questions, so we could log right in through the cloud and see those models. You see the example up there on the top right, actually a screenshot of some notes I was giving to a student on what they had been working on. So we can go in and notate their projects in docs and kind of help give them that advice that they might not otherwise have, except for when they see us in class. And that all rolls down to quality control and producing the best potential outcome of the course for both learning outcomes as well as product outcomes, and something they can be proud of and they can look back to. So providing and removing access, just like with the things, the licensing is very easy as well. So some of the key takeaways that we have and we want to put to you is to be patient with it. Not all students learn or accept this technology in the same pace. We try to make sure that we empower them to decide how to use this technology in their own way. So we ask them to produce a BIM execution plan at the start of their team projects with the expectation that that plan is going to change and the understanding that that's okay. And so we try to, spur the utilization of this technology, but allow them to kind of find their own path to it and make their own mistakes and make their own course corrections as they move through. The next thing, and I've said this a few times, but we wanted to say it one more, is introduce in stages. We found that when we present Glue and then Docs and then Team in that order and in those stages, it's a lot more accessible to the students as opposed to giving it to them all at once. It can be kind of a shell shock situation when they have all of it thrown in front of them at one time. This helps to improve the chances of success. And finally, we have hands-on experience is crucial with it. So it's not just a lecture, we have them in the environment when we're working with them so that they're hands-on from the very beginning learning how to do this. And we're working on partnerships with industry to make that even more immersive for them. The areas for improvement and some things that, hopefully you'll take away as things to consider as you're trying to put these processes into your own classrooms are that initial exercise and the initial introduction to this whole suite of products you need to devote enough time to. Without enough time, they might have trouble with it and understanding what the potential is. We've developed and we're working on continuing to develop a few guides that kind of give them little cheat sheets to move through this. And John's going to talk in a minute about some of the guides Autodesk provides to get them up and running quickly as well. So we also, throughout the semester, we kind of did it inherently, and now we're making it more formal, is to do tune-up presentations. So kind of course correct some of the things that they might have not been doing quite correctly and make sure we're addressing any of those to get them moving as fast as possible. We didn't have enough industry examples when we first started. And so we've partnered with one of our industry partners to create in-class exercises to get them moving with industry partners in these platforms to show them the real benefits. Because in an academic environment, it is hard to show the real benefits of some of this just because you're kind of in isolation, right? You're in a classroom. So by partnering with our industry partners, we've been able to provide exercises that get them that experience of the full use of the software. So those are some of the things that we learned along the way that we hope can help. And, we started all of this from essentially, nothing in this area and have built it up over the years. It didn't all happen at once. but it was a very smooth process to get into BIM 360. And we think that the students and some of the students we've had come back and tell us really enjoyed that experience and saw it as a useful thing. So some of the two last little things we're going to mention are just some of our recommendations. We've hit on this a little bit, so make sure that BIM foundation is strong before you introduce some of the collaborative platforms. They have to know where they're coming from in order to understand where they can go. We recommend some cross-course utilization. So as we mentioned, our students are from a diverse set of backgrounds. So we try to make sure that they're able to share their experiences and really gain a lot from it. So we work with different departments in different colleges and try to get them involved in that way. And next, and kind of most importantly, aside from the mixed backgrounds and experiences that will benefit them in the future, is computer access. I know you're all wondering what kind of space might be conducive. We have our picture there. That's our lab space that we have them do their hands-on training during class. But you can also see that some of them bring their laptops and are using those. So really, honestly, all of this software that we've just introduced works on any laptop that can run Revit, and even more than that, it works on mobile devices of all sorts, and it provides them that access. So once they have access to the cloud, really they can use and we found that they do use their own technology and really try to harness to its full advantage, where they're not necessarily sitting in the classroom or in the computer lab, but they're able to work from home and from wherever they need to get their work done. So those are some of the notes we have, and we'll go ahead and pass this on to John so he can elaborate on how you can get started in some of these things more technically from their side. So thank you for being here and for listening.
All right. Thank you, Dr. Issa and Nathan, for sharing out an amazing case study on the integration of cloud technologies inside the classroom. I think the strategies that you shared out in terms of rolling it out in stages is going to make it more manageable for more schools to deploy it in their own curriculum. So now I'd like to follow up with some learning resources from Autodesk that we can provide to you and your students. So hopefully you're all familiar with the Autodesk education community. This is a place where we make available free access to software for students, educators, and institutions. In addition, we also have the Autodesk Design Academy community to help educators introduce students to the world of design and construction with free hands-on supplementary projects and course materials to promote critical thinking and problem-solving skills. And we've recently added a student-led self-paced online course format to support the flipped classroom approach. Another resource for upper-level students and busy construction professionals is Autodesk Contech Academy. It's another resource to be aware of. That's an educational program that focuses on best practices to improve project performance, and it focuses on process over products. Here's just a sampling of a few of the course titles that you'll find on the Autodesk Design Academy. So anything from reality capture with Recap Pro. This is a course that actually University of Florida developed for us. We also have introduction materials and advanced materials on building information modeling with Revit. And we also have collaboration courses that feature Navisworks and BIM 360 Glue. So I'd also like to talk about our Student Expert Network. It's a global program that provides a great opportunity for students to learn, connect, and inspire others to increase their profile for employability. So students would start off in an orientation program first that provides them immediate access to online learning resources to build up their skill sets quickly, and then they can escalate into other tiers of the program where they can get access to internships and job opportunities with industry. So it's a great opportunity. And Nathan, if you could maybe chime back in here, can you share a few words about what the program meant to you?
Yeah, of course. I started with some of this technology probably about 9 years ago, I'd say, and started getting involved with the Student Expert Network. And it really was of benefit, where not only do you get the connection to other students who are doing things, you get the resources that are made available to you to help expand your knowledge, to see what else is possible, and to start to try to gain access to some of the additional lectures and different events that are happening through Autodesk. So it's a great environment for students, especially those who have a passion for this kind of stuff, to be able to connect with other people who share that passion and really advance not only their knowledge, but potentially their careers in the future.
All right, thanks, Nathan. So you should all be aware that we also provide the ability to gain industry recognized credentials through our product certification exams. So the ones that would be appropriate for this industry would be Revit, AutoCAD, and Civil 3D. And I will state that that is fee-based, so that's the only part of the program that's not free. And just to kind of close out here, obviously the future technology of how work gets done is moving towards the era of connection that we focused on today to help accelerate project delivery, to increase collaboration so that new means of building, designing, and operating building and infrastructure systems is empowered in the era of connection. So now is the time for students to use the same tools that industry stakeholders use to manage projects collaboratively and effectively while reducing risks. So these are the technology career roles that might be of interest to you. I know scanning the job boards, the BIM manager roles seem to be in high demand, so that might be attractive to the students that are on this presentation. And then here are the technology skills that we see that would be appropriate to be mapped against those career roles. So these are things that industry would expect you to have entering into those roles. So let me quickly wrap up with next steps. First item is to download our desktop software from the Autodesk education community. Apply for a BIM 360 education grant, which I'll share with you in the following slide in just a moment. Download and enroll in curriculum from our Autodesk Design Academy. As Nathan mentioned, I did create specific BIM 360 guides for administrators and end users. That can also be found from the Autodesk Design Academy on the Take a Webinar page for Connected BIM. So I'll post that later today, if not tomorrow, so you can start taking advantage of that resource. And then for those of you that may not be familiar, there is a BIM 360 Glue add-in for the 28 desktop products that will need to be installed separately. In the 2017 release, it was automatically built in, but for 2018, you'll have to manually download and install that. So moving on to the education grant offering specifically, our BIM 360 solutions includes Docs, Glue, Field, and Plan. And you can apply for the grant through the Autodesk education community at the URL shown in blue. It's not live yet, so hopefully as early as next week, it should be live, and then you can all automatically go ahead and submit your application, and it takes about 10 business days to turn those services on for you. So let me talk about the grant terms specifically. We're offering these grants to institutions only. However, there is some flexibility. So if the construction program wants to submit a grant independently of other programs on campus, you're welcome to do that as well. The grant term is for 1 year, and it is renewable at end of term. And just to be clear, once Autodesk provides you access to these services, it's the responsibility of the institution to manage and distribute those cloud services to the students via their email address associated with their Autodesk ID account. So I'd like to move into the questions and answers period. And if you can give me a moment to scan the questions pane, I'll try to answer some of those questions that you may have thought of. In the questions pane, go ahead and type in your questions if you have those thoughts now, and hit the send button. And let me kick this off with a question that I have for University of Florida. You know, today you showed a great example of how you integrated connected BIM technologies at the graduate level. I would imagine that there's great interest in understanding how you would introduce these collaboration concepts at the undergraduate curriculum level. And maybe you can refer to the good, better, best stage context that you had revealed in your presentation.
Yeah, not a problem, John. So we do have 2 undergraduate courses that focus on building information modeling, And as far as introducing kind of the collaborative side of things, I think at the undergraduate level, things, you don't quite push as much technology in one semester, so it's spread out a little bit. So something that we've seen can be successful is to kind of, as much as we said building those fundamentals, build it even more so. And so we not only do it through the classroom where we kind of start with that base level of understanding what those platforms do, but I think the final stage, our best level at collaboration, really happens in kind of that second class. That's where we'd focus and allow them and open up that world of possibility. And we also do it with our competition team. So that competition team that we mentioned, we have kind of a cohort of undergraduate students who are passionate about that technology. I think this past year we had about 8 students actively on the team and a bunch who came in just to learn the software and technology. I mean, we bring them through all of this from start to finish, where we start with that coordination, move on to the management, and add the collaboration side. So, at the undergraduate level, it's definitely not something that's out of the question. It just happens, I think, a little bit more gradually to make sure that they're not overloaded with what they're trying to also get their hands around, which is the whole idea of construction and design.
Okay, super. So one question that's come in from the audience is they would like to understand better what kind of skill sets do the students have coming into the course. They are just thinking that that's a lot of tool sets to introduce to students, and they would like to know maybe better how you got them onboarded as quickly as possible in a strategic way.
Yeah, that's a great question. So when we start the course, the idea is that they should have their techniques and their construction knowledge or their design knowledge kind of in hand. So the idea is, since they're graduate students, they kind of come in with some of that. I mean, we kind of start from assuming that they don't have any technical knowledge within building information modeling, other than maybe some high-level understanding of what it is. And, plan reading and that sort of thing is something that we expect. But as far as actual model experience, we don't expect anything. We kind of start from the beginning. So we move through a lot of that, and we build those for the first 2 to 3 weeks. We focus on getting them into the platforms, understanding where everything is, how to embed information in the models. And it is a lot. In the course of the semester, we warn them at the beginning how much work it is and how much effort it takes. And because they're graduate students, I think a lot of them are prepared for that. And honestly, we find that a lot of them have the passion for it, and so they want to put more effort into it. So we make sure they understand that it's going to take not only in-class time, but out-of-class time as well. But we build from the basics. So we start assuming nothing, build them up in their modeling environment with the information management, and then add all of these things on throughout the course of the semester. And when you look at it as one giant, body of work, it seems unmanageable. But when you introduce it that way and kind of slowly and in stages and build them up from the beginning, I think it really does prove to be successful. And the other thing is, those that come in with some experience, because we do have those, they always learn things too. So, I try to make sure that they understand that not only are, I'm still learning new things, Dr. Reese is still learning, it never ends. This technology never ends. And so that they kind of eliminate that idea that they're behind and they can start from the beginning. And we try to level their experience in their teams as well, so that they can learn from each other.
All right. Thanks, Nathan. So we're over time. So let me wrap up with one answer to one important question that was asked, which is, we mentioned and shared out collaboration for Revit, but they didn't see it in the education grant offering. So that leads me to this part right here. So today, the collaboration for Revit is a manual grant process. And what I'm asking you to do is to submit your request for a grant of collaboration for Revit to connected.bim.edu@autodesk.com and put grant request in the subject line so we can discover that more easily. And then we can share back with you the grant forms that need to be filled out. You would return those back to us, and then we can get those services enabled for you. Kind of wrap things up here. So in summary, you heard through the University of Florida's case study how Autodesk connected BIM solutions transform the student experience by bringing industry collaboration workflows into the classroom. So connected BIM means collaboration with impact. So please join us in preparing the next generation of builders. And this concludes today's presentation. Have a great day.